Alright, we have one more shot at practicing factoring and solving quadratics, because this is a big chunk of what's going to be on the test coming up Friday, in addition to the newer stuff. So, if you're watching this video, love ya. You're doing what I asked you to do, as long as you're not copying off the video. Alright, put the pencil down. Step away from the homework. Watch and then go back and do it yourself. Then I love you. Alright, now, number one. First step of factoring is to look and see if there's a common factor. I don't see a common factor, so I will go ahead and start shooting for the binomial times binomial. So that's going to be 2x squared can only be 2x and x. 35, the first thing that comes into my mind is 5 times 7. Alright, technically it could be 1 times 35, but I'm betting on the 5 times 7. So I will try 5 times 7 like that. Now inner, I've got 5x. Outer, I have 14x. I'm trying to get this middle of 3x. There's no way to get 3 out of 5 and 14, no matter how I pick the signs. So that's not looking good. So instead, I will try switching these. Alright, so I will try the 7 here and the 5 here. If I do it that way, inner, I have 7x. Outer, I have 10x. Again, I'm trying to get this 3. I can get 3 if I do a negative 7 and a positive 10. There's my negative 7, and this will give me the positive 10. Also, a negative times a positive is a negative, so this is it. So that's why your answer is 2x minus 7 times x plus 5. Alright, looking at number 2. First step of factoring is to look for the common factor. They're both divisible by 2, so let's go ahead and do that. So if I pull out a common factor of 2, alright, I put that in front of the parentheses. I don't get rid of it, I put it in the front. But anytime I pull out a common factor, I divide by it to see what goes on the inside. So that's going to give me 9x squared minus 25. So then I recognize this is the difference of two perfect squares. So I keep going. So I put 2, and then I put 3x plus 5 and 3x minus 5. Okay? And then that's it. So the answer should have been 2 times 3x plus 5 times 3x minus 5. So then we look at number 3. Number 3 is the difference of two perfect cubes. So I have to remember that whole pattern. And the pattern is, it's always going to factor as a binomial and a trinomial. The binomial is just the root, the cube root of each of these things. A to the third power comes from a. Alright, let's bring down the minus sign. 125 comes from doing 5 to the third power. So I bring down a 5. And then b to the third power comes from b. So my binomial is a minus 5b. Remember, I had suggested that you make a list of these perfect cubes by taking your calculator and doing 1 to the third power, 2 to the third power, 3 to the third power, and so on. So that would give you 1, and 8, and 27, and 64, and 125. So there's the 125 I'm referring to. Now, when you look at the trinomial, the beginning and end of it will come from the terms of the binomial. If I take the first term and square it, that gives me a squared. So this will be a squared. If I take the second term, 5b, if I square that, I'm going to get 25b squared. So I'll put plus 25b squared. Alright, sometimes kids forget about the b and they just put 25. Sometimes students will just put b and they'll forget to square it. So just remember, you have to square it all. 25b squared. Now that just leaves the middle. For the middle, we multiply these together. But it'll be the opposite sign. So since this is negative, then we'll put positive. Okay? But then we'll just multiply a times 5b. So that just makes 5ab. So that's the answer. Alright, so that's why the answer is a minus 5b times the rest of it, a squared plus 5ab plus 25b squared. Okay, look at number 4. What is the first step of factoring? Common factor. There is a common factor here. 7 goes into both of these, so I'll have a 7. But also d. See how they both have d's? They both have at least one d. So because of this, I will pull out d. So 7d. Alright, now that means I'm going to take the 7d and divide. 35 divided by 7 is 5. D to the third divided by d is d squared. 14 divided by 7 is 2. And then the d's cancel. So I have this so far. Now, when we had the quiz, a lot of you did this, and then you kept going. You called yourself factoring this. There's no way to factor. There's no way to factor this. We've only learned 2 ways to factor something that just only has 2 terms, a binomial. And that's the difference of 2 squares. Well, this is not even subtraction. Or when it's 2 cubes. And none of these are cubes. So this is unfactorable. So we're done. So the answer is 7d times 5d squared plus 2. That's it. Okay, let's look at number 5. Whoa, wrong. Alright, looking at number 5. What is the first step of factoring? Look for the GCF. Okay, there is one this time. 3 goes into all of these, doesn't it? So you should pull that 3 outside of parentheses. So that's going to leave behind, because I'm dividing. So that's going to leave behind x squared minus 7x plus 10. Okay, fine, but probably this trinomial will factor further. So we should definitely try that. Let me do it over here. So so far I've got 3. Okay, so looking at x squared, that's definitely going to be x times x. Looking at the 10, alright, that's either going to be 2 times 5 or it's going to be 1 times 10. Now, I got to tell you, because there's no leading coefficient other than 1, I can look right now and see that 2 and 5 can make 7. So I'm really feeling good about the 2 times 5. Now, I want to get a negative 7 result. So just in my mind, I'm looking at the inner is 2x, the outer is 5x. I'm trying to get negative 7. That would be negative and negative to make negative 7. So there you go. But I also need to make sure it makes positive 10. Sure enough, a negative times negative is positive. So kabam! Got 'em. So 3 times x minus 2 times x minus 5. Okay, let's take a look at number 6. Now, some kids wanted to immediately try to do the sum of 2 cubes because they see this third power and they go, sum of 2 cubes, let's do it like number 3. But there's 2 problems with that. One problem is 2 and 54 are not on the list of cubes. See? There's no 2, there's no 54. So these numbers are not perfect cubes. The other thing is you're forgetting the first step of factoring. What's the first step of factoring? That's right. Look for a GCF. And there is one. The common factor is 2. So before you do anything else, you definitely need to pull out that 2. So then you see, and remember we're dividing, so you see that really we have x to the third power plus 27. Now x to the third power is a cube. Is 27 a cube? Yeah, boom, it's 3 to the third power. So now that tells us that this is the sum of 2 cubes, so we can go ahead and do it. So we bring down the 2, of course, don't lose that. But the sum of 2 cubes always factors as a binomial times a trinomial, a 2-piece times a 3-piece. The binomial is just going to be the root of these. So I'll have x plus 3, because 27 comes from doing 3 to the third power. Okay, so there's my binomial. My trinomial is going to have a beginning, a middle, and an end. But the beginning and the middle is what we do now. Okay, we square these, and that gives you the beginning and the end. If I square this, I simply get x squared. If I square this, I get 9. So I put plus 9. For the middle, we multiply these two things. Alright, I'm talking about x and 3. We multiply them. So that's going to make 3x. But we do the opposite sign. So since this is positive, we'll do negative. So that's it. This is the answer. Alright, maybe I can cut and paste it. Whoa, fail. Alright, so what you're saying is it'll be simpler just to copy it over. Alright, so 2 times x plus 3 times x squared minus 3x plus 9. Alright, fine, that's number 6. Take a look at number 7. Oh, look, 4 terms. When we had 4 terms, I taught you to try grouping. That should be your first guess. So if I group these, look for the common factor. Let's see, if 3 goes into both, and I see they all have a's, so that's 3a. So I will factor out a 3a. And then inside, remember I'm dividing, so the 3's cancel out, and that just leaves a minus, alright, 3 goes into 6 twice, and the a's cancel out. So I have 3a times a minus 2. Okay. Now I do the same thing with the second group. 2 goes into both of these, so I put plus 2. And I see they both have a b, so I'm going to go 2b. Alright, once I divide everything by 2b, the 2's cancel, the b's cancel, I have a. I bring down the minus sign. 4 divided by 2 is 2, and the b's cancel. So I have this. Some kids stopped there. Don't do that. Notice how we have a minus 2 here twice. That is a common factor. Just like we pulled the 3a out and put it in front, we need to take the a minus 2 and pull that out front. Okay, like this. A minus 2. Notice it is not a minus 2 squared, just like it wasn't 3a squared when we took 3a away from both of these. We're just undistributing the a minus 2. So if I take that away, what's left? Alright, the two things that I have here in blue. So that's going to leave 3a plus 2b. So there you go. That's the answer, number 7. Okay, so let's see if I can do one more problem before my meeting, my lunchtime meeting. Alright, sorry, I had to drink some tea. Save my voice. Looking at number 8, solving by the quadratic formula. The quadratic formula says if you have an equation in standard form, ax squared plus bx plus c equals 0, the standard form, then the solutions will be x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. There's a quadratic formula. Now this problem is not in standard form, so this 4x needs to get over into the middle. We can make that happen by subtracting 4x from both sides. So that's going to give me 2x squared minus 4x minus 1 equals 0. That means that a is 2, b is negative 4, and c is negative 1. You know what? I better go have lunch and go to my meeting. You won't miss me. For you, it'll be like I just kept right on teaching. Now, I do not recommend that you take the A, B, and C and just plug it all in. What I want you to do is do your discriminant first. Your b squared minus 4ac. Alright, that is what I've told you to do, people. The discriminant is b squared minus 4ac. Okay, in this case, that is negative 4 squared minus 4 times 2 times negative 1. And I encourage you to write that as 16. You know it's positive 16. Do not write negative 4 squared, just do 16 minus 4 times 2 times negative 1. And we can just put this in the calculator. Okay? Yeah. Like this. 16 minus 4 times 2 times negative 1. You can just type it in just exactly the way it looks on your paper. So you should be getting 24. Alright, if you're not getting 24, then guess what? That's what you did wrong. So we're finding that the discriminant is 24. You should always do that first. Okay, then when you go to do the actual problem, you know, the quadratic formula, it should look like this. Opposite of b. So b is negative 4, so we'll do the opposite of b, which is positive 4, plus or minus square root. Under the square root is this 24. All over 2a. Okay, a is 2, so 2a is 4. Alright, do not type all of this in your calculator. Please notice you can't cross out the 4s. Some people wanted to just cross out the 4s. Can't do that. You have to do all three things or nothing. So don't try to do anything with the 4s right now. Instead, the only thing I want you to put in your calculator is the square root of 24. Alright, let's see what that is. So square root of 24 Alright, that is 2 radical 6. So when you rewrite this, what you have is 4 plus or minus 2 radical 6, okay, all over 4. Now, I'm going to draw a heart. That's right, a heart. Because the last thing you're supposed to do, I mean, we're almost done, but a lot of people got this far and wound up losing points because they reduced wrong. Again, I can't cancel out the 4's, but what you want to do is draw a heart. Draw a heart around these 3 numbers, like this. Alright, see the heart? I don't know what teacher came up with this, but I like it. Alright, if you can reduce all 3 of these numbers, notice it doesn't include the number under the radical, just the number like in front. It has to be all 3 or nothing. If all 3 of these are divisible by the same number, do it. All of these are divisible by 2, so I would go ahead and divide all of these by 2. And that will be your final answer. Alright, if this was a 3 or something, then I couldn't do anything. Or if there was no 2 here, if it was just a radical 6, then I would be done. I would not do anything with the 4's at all. It has to be all 3 of these numbers or nothing. But if I do go ahead and divide all those by 2, then I'm going to get 2 plus or minus, okay, 2 divided by 2 is 1, and I'm not going to put a 1, so I'll just put the radical 6. And then same thing down here, 4 divided by 2 is 2. Okay, so look, this is your answer right here. And again, I cannot cancel out the 2's, or I will not make a 1 or anything. I just have to leave it like this. Okay. Solve by factoring. To solve by factoring, pardon my yawn, we need this to be in standard form. So let us subtract 6x from both sides. Alright, that gives me, let's see, 9x squared, 10 minus 6, so 4x is equal to 5. Now that 5 still needs to go, so let's subtract 5 from both sides. So that will give me 9x squared plus 4x minus 5 equals 0. Okay, so I'm solving by factoring. So now I need to factor this. Alright, there is no common factor, so we start this process. Now 9 squared. This can either be 3 times 3 or 1 times 9. 5 has to be 1 times 5. There's no other option. So I'm going to start with 3 times 3. I always start off with the numbers close together. So I will start off with 3x and 3x and see how that goes. Alright, if I do this, now I'll do the 1 and 5. 1, 5. Inner, I have 3x. Outer, I have 15x. I'm trying to get positive 4x. Is there any way I can get positive 4 out of these two numbers? If I pick the signs right? No, there's no way. So that means this is not working out. And since 1 and 5, or even if I reversed it, it would be the same thing, is not working, then that means the 3 and 3 option is not working. So I'm going to throw out the 3 times 3 option, and instead I will go with the 1 times 9 option. So 1x, so instead of 3 and 3, I'll do the 1 times 9. Okay, except for I'm not really going to put a 1 here. Okay, it's just x times 9x. Alright, so this is going to change my whole inner-outer situation. Now inner, I have 9x. Outer, I have 5x. Again, I'm trying to get positive 4. I can get positive 4 if I let this be a positive 9 and a negative 5. Okay, so putting a plus here will give me my positive 9 inner. Putting a minus here will give me my negative 5x outer. Also, a positive times a negative is a negative, so even that works out, so that means this is good. Okay, I'm going to erase this, get out of the way. Some people did this and stopped. Don't stop. You need to keep going because we are solving. Solving means find out what x equals. And we will get that by setting x plus 1 equals 0. Subtract the 1, you get x equals negative 1. So that's one solution. If I set this equal to 0, okay, I feel like I need more space over here. So if I do 9x minus 5 equals 0, add 5 to both sides, so I get 9x equals 5. And then divide both sides by 9. Alright, sorry my voice is so tired, you guys. I never get a lot of sleep, but sometimes it catches up with me. And this is one of those days where I just feel literally sleepy. Okay, so then there you go. These are the two solutions. Okay, so negative 1 and 5 over 9. You have to keep going till you get all the way to this. Okay. Number 10, we're supposed to solve by completing the square. Now this 13 has to be a special number. Hold on. Having some V8, man, for lunch. I need to get rid of this by subtracting 13 from both sides. So that's going to give me x squared minus 6x, leave a space, is equal to negative 13. Now I can do half the middle squared to complete the square. Half of this is 3, 3 squared is 9, so I'll put plus 9 on both sides. Now I can factor this. So this should factor as the same thing twice, or else I did it wrong. And this is going to make negative 4. So x, 9 will be 3 times 3, and looking at this, it'll be minus. X minus 3, x minus 3. The point of that is so I could write this as x minus 3 squared equals negative 4. I said squared, but I put third power. Okay, squared. The point of that is so that now I can take the square root of both sides to unsquare this. Do not forget your plus or minus. Anytime you take the square root of both sides, the solution will be plus or minus. Two solutions, really. So that cancels out this squared exponent. So I just have x minus 3 equals plus or minus. Now, here we have this negative under the radical. You should bring that out as an I. Now, if this were a 5 or something, I would just stop there and just bring the 3 over. But since it is a perfect square, then this becomes, the square root of 4 is 2. So we go ahead and put 2i. Alright, one more step. We add this 3 to both sides and put it in the front. So that is going to give me x equals 3, it's this 3, plus or minus 2i. A lot of kids left off the I, and then they wanted to do 3 plus 2 and get 5, maybe, or 3 minus 2 and get 1. So if you got 5 and 1, then you forgot about the I. So don't forget, if it's negative under the radical, that comes out as an I, and that I is not going anywhere. So that was number 10. Alright, last one. Solve by completing the square. You have to really watch out on this problem because of this 3. It causes two major mistakes that kids make, but let's get started. First of all, we need to get rid of the 7, move that away by subtracting 7 from both sides. So that's going to give me 3x squared minus 6x, leave a space, is equal to negative 7. Now here's the first common mistake. Some kids will think that it's time to do half the middle squared right now. Half of this would be 3. 3 squared is 9. Some kids think we're going to do a 9. No, we're not going to do a 9. Before we do half the middle squared, there cannot be a coefficient here. This has to be factored outside of parentheses. So the first thing you need to do is pull that 3 out, like that. Okay, now I'm dividing, right? Like I do. Because it's 3, I'm dividing by 3. And that tells me what to put inside. So these 3's cancel, so I have x squared. Negative 6 divided by 3 is negative 2, so I have negative 2x. Okay, you have to do that first. Now we do half the middle squared. Half of 2 is 1. 1 squared is 1. So instead of a 9, I'm doing plus 1 on the left. Now the other common mistake is if kids get this far, if they get to the plus 1, then they think I'm going to do plus 1 over here also. But I'm not going to do that because this 1 that I just added is inside of a parentheses, a pair of parentheses. And distributive property, if I were to do the distributive property, I'd wind up doing 3 times 1, which is 3. So this 1 looks like a 1, but it's really 3 times 1. It's really a 3. So for that reason, I need to add 3 to the other side in order to balance this out. Okay, so that's a common mistake. 3 times 1 is 3, so you add a 3. And the rest of the problem, there's still a couple more pitfalls, I guess. Alright, this is a tough problem, no doubt about it. A lot of steps, a lot of moving parts. See, negative 7 plus 3, that's negative 4. Okay? Now, this will factor as the same thing twice. X minus 1, x minus 1. That means we've got 3 times x minus 1 squared is equal to negative 4. Now, some kids want to take the square root right now. You can't take the square root with that 3 sitting there. We just need it to just be x minus 1 squared. So we need to get rid of the 3 by dividing both sides by 3. Okay? And I'm going to copy it over here, bring it over. So that's going to give me x minus 1 squared is equal to negative 4 over 3. Now I can take the square root of both sides. Okay, but not until now. Do not forget plus or minus anytime you take the square root of both sides. Now that will give me x minus 1 equals plus or minus. Now once again we have this negative under the radical. And I told you to bring that out as an I. Okay, so plus or minus I over 4 radical 3. Now, I'm not sure if your calculator will do the square root of 4 radical 3. I don't think it will, but I'm going to try. Whoops, I messed up. Let's see, square root of, 4 over 3. No, it just gives you a decimal, and that's definitely not what I want. So, if this were a quiz, okay, let me take a step forward, because let me show you what I would accept for now. If I went ahead and added 1 to both sides to get this x by itself, okay, make sure to put this 1 in the front, in fact. Let me move it over. Alright, it goes in the front before the plus or minus. So I'm going to get x equals 1 plus or minus I radical 4 over 3. Alright, I would accept this. Alright, it is not the most acceptable answer because we like to simplify this a little bit more. But at this level, I'm just going to totally accept this. But let me go ahead and show you what you actually are supposed to do with this radical 4 over 3. Please understand that square root of 4 over 3 is the same thing as square root of 4 over square root of 3. Okay? And you know that the square root of 4 is 2. So this is like 2 over the square root of 3. So we're making progress already. Now, you could put this in your calculator, is the thing. Okay, watch this. 2 over the square root of 3. That is 2 radical 3 over 3. And this is really what you're supposed to do. So this gives you 2 radical 3 over 3. So all this came from radical 4 over 3. Okay, so what you're really supposed to do is replace the radical 4 over 3 with 2 radical 3 over 3. So the most perfect answer would be 1 plus or minus, and actually, okay, I'm going to go ahead and write this 2 radical 3 over 3, because where does the I go in all this? Am I going to just put the I in the front? Well, the proper place for the I in this is to be right here in the middle, between the 2 and the radical 3. So if you really want to be a rock star, and who doesn't want to be a rock star, then this is what you would put. Okay? Oh, look at that. Time for 5th period. Just in time to finish this video. I hope you did not copy me, because it'll show up on the test. Alright? If you did copy me, print out a blank copy of this and do it yourself. You guys need to do these problems over and over again until you can do them yourself without copying off of me and get the right answer. I'll see you on the next video.